Hello everyone, and welcome to my second tutorial on how to create full-stack web applications. In this tutorial, I'm going to be focusing on testing, and more specifically, I'm going to be focusing on JUnit and Makito, and I'm going to be covering basic usage of those libraries. And I'm also going to be showing you guys a demonstration on how to do test-driven development. So, one of my motivations for doing this tutorial is that I like to use some test-driven development in later tutorials just because I think that it would illustrate the behavior of the program in a very explicit way, and it would also provide more planning in our project, and it would also show you guys the thought process that goes behind test-driven development and maybe make you think about developing code in a different way, which I think that would be very interesting to do a tutorial series with some test-driven development. So I'm going to be first I'm going to show you guys how to use basic. I'm going to show you guys basic usage of JUnit, which allows us to test our Java classes, and then I'm going to show you guys how to use Makito to mock our objects and help facilitate test-driven development. So basically, the first thing we're going to do is we're going to open up the project we were working on last, and we're going to go to our POM and navigate to the dependency section, and I'm just going to create a new section here called testing dependencies, and I'm going to put JUnit on our dependencies list here. So go to MVN repository and then search JUnit, and then you want the JUnit artifact. So go ahead and click that, and then you'll select the 4.11 version and copy this dependency into our Maven file. And we're also going to want to set the scope. But now JUnit, when it's JUnit is integrated with Maven, so during our test lifecycle, Maven is going to look in a certain directory for our tests, and we really only need JUnit on the class path during testing, and we don't really need it in production. So we're going to set the scope of this to test, and that will ensure that when Maven creates a production version of our program, that it doesn't include JUnit on the class path. And the second dependency we're going to include is Makito. So go ahead and go to MVN repository and search Makito, and then look for the artifact Makito all. So we're going ahead and go and click this, and we're going to select the 1.9.5 release version, and go ahead and copy that, and we're going to place that in our dependencies section, and we're going to set the scope to test. Also, because we don't really need mock objects in our production environment. So now I'm going to show you guys a basic test, and basically, for Maven to find our tests, it needs to look in a certain directory. So we're going to create that directory so that Maven can find our tests. So just go ahead and go up here to source and right click and create a directory in here, and we're going to call it test, and Maven will by default look in this directory for our tests. It will look also before it starts looking for our tests, it also needs to go through another subdirectory called Java, which is our Java source code. So it will look in the directory test/Java for our tests. So we're going to go ahead and create a test here. I'm going to call it tutorial.calculator test. And because I'm going to show you guys how to I'm going to create a calculator and test a absolute value function. First, I'm going to do the right code, test first approach, and later on I'll show you guys how to do the test first approach and create the code later, which is like the test-driven development approach. So first, I'm going to go and I'm going to create a go ahead and before I add anything to this class, I'm going to double click test, and now basically if I double click the test lifecycle and Maven runs the test lifecycle, normally what will happen is it will show 0 tests are ran if there's no tests on in our directory. So this just verifies that it is 0, and we're going to try to increase this to 1 so that we have at least one test running. So I'm going to write use a test annotation, and I'm going to annotate a function with this. And I'm going to call it test ABS because we're going to test the absolute value function. And I'm going to double click our lifecycle, our test lifecycle again. And it should say that 1 test was executed and 0 failures occurred. So right now we have a test happening, but right now there's no failure. And the way JUnit works is this test is executed within the JUnit framework, and it's executed within a test runner. And what happens is that if this particular function here throws any exceptions, the JUnit is going to say that this test failed, basically. So there's actually a way to we're going to force a failure by making a false assertion. So we're going to use JUnit's assertion API. So go ahead and do a static import of JUnit's assert library. It's org.junit.assert. And that includes a number of different assertions. So we can assert one array equals another array, or we can assert something's false, or what have you. There's a lot of different functionality here, and I'm just going to make this test fail by forcing creating a false assertion. So I'm going to write assert equals 2 and 1. So if I double click test now, what's going to happen is we're going to have a failing build because we have a failed test, and it says that the expected value was 2, but the actual value was 1. So so the way JUnit works is in the first parameter you specify what the expected value is, and in the second parameter you write what the actual value is. So basically what we can, and if I do this, if I set it like this, then it's going to pass, and you can see that it passes. So 0 failures. So what I'm going to do is I'm going to create a calculator class in our tutorial directory up here, tutorial.calculator, and all the classes up in our Java directory are included on the class path of our test classes. So if I can actually access calculator without having to import it. So I can do calculator calc equals new calculator. And basically what we want to do is we want to have a absolute value function and test that. So I'm going to go to our calculator here, and I'm going to create a test here. I'm going to call it public int ABS for absolute value, and put in here a value of arg. And if the arg is less than 0, I'm going to return the negative arg, and otherwise I'm going to return the arg. So I'm going to now create now this is just for demonstration purposes. This is this is just for demonstration purposes. It's a very simple function, but it's just to get the idea across. So I'm going to go back to our calculator test, and I'm going to call calc.abs of -4. So I'm going to write int actual equals this, and I'm going to actually say expected equals so expected is 4, so we're expecting 4, but the actual is what the function actually calculates. So we're going to put in here the expected value, and then we're going to put in the actual value. So if this works correctly, it should execute. It should work, and it says success. But if we break, if we say something's not, if we actually break it by going back to our calculator, and well, first let's see how we'll break it. We'll say that it returns a negative number, so that these don't match. So if I go back over here and I make it always just return if I just make it so that it always returns arg, so I just write return arg, then it should fill. So you can see that our test is running, and it says if we go back to our test, we can see expected was 4, but actual was -4. So we just broke our test, so our test is working. And so what we'd like to do here is, so this demonstrates how to make a test, and you could just like do this and put in calc.abs of -4 just to clean up this code. But basically, this demonstrates the use of basic assertions and using JUnit's assert API. The next thing I want to show you guys is how to another function, another JUnit annotation called before. So before executes before each and every test. So if I write before and then I create a function here, before void setup, and let's say over here I just put in here new calculator, and I make an instance variable here for calculator. Okay, so now I have an instance variable of calculator. I instantiate it over here in our setup method. Now, setup, because of the before annotation, setup will execute before each and every test. So this is a good way to initialize our variables before each and every test. And so if I double click this, it should work without returning a null pointer exception. If calc was null, it would have triggered a null pointer exception. So basically what we're going to do here is I'm going to show you guys how to set up a mock object. So first thing, I'm going to just illustrate how to use a mock object, and then I'll show you guys how to use it for test-driven development. So first, I'm going to show you guys how to mock our calculator. So basically, the way you mock our calculator is you can write @mock annotation here, and then so that's an annotation to Makito that we want calculator to be mocked. And then over here, we're going to call Makito annotations so that we can have that field injected. So Makito annotations, annotations.init mocks, and then we pass in this test class. And what that does is it triggers Makito's injection mechanism to inject the mock into this field. So basically, it's going to inject calculator into the calc field here, and basically we don't need this anymore. We don't need to say calc equals new calculator. We can just erase that, and Makito should instantiate our calculator here. But in order to actually tell calculator to have calculator do something, we need to specify its functionality. So in order to do that, you can because right now we don't calculator. This is not going to inject this. It's not going to inject this implementation. Calculator is going to mocking the calculator is going to create a implementation that returns that does nothing. So just to illustrate that, I'm going to create a assertion here. I'm going to erase this one, and I'm going to just print out something here. No, I'm going to assert something. I'm going to assert assert equals the value 0, and then calc dot ab of 20. So if I do this and I run this, what's going to happen is it's going to say failure. Okay, so what's going on is I have a let's see. Oh, okay. So actually, is a build success. I misread something. Okay. So it was a successful build. The test run or one, and so basically, calc by default on integer fields, Makito will return 0. So if you put anything in here, it will return 0 here. So this is mocking our calculator object, but it's not mocked in the way we like it to be. Let's just mock it so that it actually returns something meaningful. So say we want a working calculator. What would a working calculator do with an absolute value? So let's create that behavior using Makito's mocking framework. So we're going to do a static import of import Makito, static import Makito, this one, org.makito.makito, and we're going to import all its static functions, and it has a number of static functions, and you can actually mock objects with these functions and change their behavior. So now I'm going to change a behavior calc by using the when function, a static function of Makito. So I'll write down when. Let me just make this window a little bigger here. Right, so when calc.abs of 20 of, let's say, negative 20, return, let's say, then and say you want it to return something when you call the abs of negative 20, you write dot then return, and then we can specify a value here. So I'm going to say 20. So this is a working calculator I'm mocking, and so I'm going to assert equals 20, and I'm going to put in the abs value here, negative 20. Now, if we mocked our object correctly, when we call this function, this function here, it should return this value. So what we're going to do here is we're going to run this test, and let's see. Okay, so the test run or one is 1, and there's no failure, so it's working the way we expect, and we could even change this so it's a failing test. So we could say and then return negative 20, and it should make a failing test, and it will say up here expected 20 but was actually negative 20. So basically Makito is a way to change the way an object behaves, and this is actually very effective functionality for doing test-driven development, because you can actually an object is composed of itself and the different dependencies that it has, and if you can mock the dependencies and how it interacts with those dependencies, if you can mock those dependencies and change their behavior, you can design the behavior based on the way you can design the behavior of the object you're testing based on the interaction with the mocks. I'll show you. It sounds a little confusing, but I'll show you guys with an example in here in a moment. So in order to do test-driven development with this, we have to have an object with dependencies. So I'm going to create an example using an analogy between a car or a vehicle and an engine. So say you have a vehicle and say you have an engine in your vehicle that has an increase RPM function. So when you call the accelerate function on your car object, it's going to call the increase RPM on your engine, and when it calls increase RPM on the engine, it basically will check. You'll also have a function that checks basically if you increase the RPM and whatever. You also have a function to get the RPM, and say the RPM is more than 5,000. then you want to display a warning. You want to have a function that displays a warning to the user, to the driver of the car. So in order to do that, I'm going to create a Java class. I'm going to call it car here. And so car is going to be the object under test. It's going to be the code. We're going to test car and the car's functionality, and then we're going to add functions to. We're going to add implement those functions that satisfy the tests. So I'm going to create a function here called public. First, I'm going to add a way for us to inject our dependency. So I'm going to write down public car engine, and this dot engine equals engine, and then I'll generate that field here. I'm going to change you don't want a final field. That will generate bad behavior. So now we're going to create an interface for engine. We're not going to implement engine. Engine is going to be a mock object, and we're going to design our car based on the way engine behaves. So I'm going to create the engine interface here, and I'm going to write down engine here, and I'm going to have a function called increase RPM, and public int get RPM. So in car, I'm going to have a function called accelerate that I'm going to be testing. Now, in order to test, so basically, and I'm also going to have the car is going to have a message containing the warning message. So I'm going to have string message here, warning message, and I'm going to generate a field for that, getters and setters, I mean. Oh, my mic's having trouble here. Okay. All right, so I'm going to need to generate this field here. Oops, wrong one. Generate. Alright, so now we have a way to set and get our message. So now I'm going to create a function called accelerate that will do what we want. That will create the implementation for us. So now I'm going to go to a calculator test here, and now we're going to state the way the engine behaves. So the engine has to go over 5,000 for our warning to actually be well, before I go any further, let's just go back in our car class, and we'll have something called, we'll actually implement part of this function. We'll say we'll call it engine dot increase RPM, right? So that's fine. But our test is going to add the rest of a functionality for this function so that it's operating correctly. So the RPM will be increased if we execute this, but we'd like to add some additional constraints. So I'm going to go back to our calculator test here. And instead of calling this calculator test, I'm going to rename this car test. Oops. Oops. And I'm also going to change the object we're mocking to the mock object to the engine class. And also, I'm going to add, use a new annotation here. I'm going to use the annotation inject mocks, and I'm going to set a field here called car. And what inject mocks does is it injects this mock object into the constructor for car. So this engine, I'm going to actually rename this to engine here. It's confusing. Okay, so this engine object is injected into this car based on constructor injection. So basically, before each and every test, it will re-inject our mocks, a clean representation of our mocks that we can actually change the behavior of before each test. So each test can configure the behavior of a mock separately. So for example, and I'm going to erase this. So I'm going to, each test function can reconfigure the mock object engine separately. So I'm going to change this function called test warning, and I'm going to make a failing test here so that and we can actually implement functionality to make it pass. So we want it so that if the engine revs over 5,000 RPM, that a warning is displayed in the car. So what I'm going to do here is I'm going to use the when static function and call. I'm going to put engine dot. I'm going to put engine in there and write dot get RPM. So when we get RPM, then return let's say 6,000. So in this situation, the way our car should behave is it should actually display a warning. So I'm going to assert that that's true. So but first I need to call accelerate to actually make that happen. So I'm going to write car.accelerate, and then I'm going to check that that the message was set. So I'm going to write down assert equals car dot get warning message and slow down. So if I double click test now, it should be this test should fail. And let's see the error. It says test warning failed. Expected null, but expected. Oh, I accidentally mixed up the expected and the actual. So I'm going to put car.get warning in the next parameter. So slowdown is the expected. We want car.get warning message in the actual. So I'm going to run the test again, and it's going to say expected is slowed down, but actual was null. So we're going to implement the functionality to make this message get created based on this behavior of a mock object. So I'm going to go to our engine, to our car class, and I'm going to go to our acceleration function, and I'm going to write if engine dot get RPM is more than 5,000, then set the warning message equals slow down. And if we test this now, our test this functionality in our car class should work now based on the behavior of mock object. So if we double click on test, our test should pass. Right, you see, so we get a success here because the message is slow down. Okay, so our mock object is being injected. Our engine mock is being injected to our car. Setup is called before each test function, and that's what initializes the injection process. And then we set a custom behavior on our mock object, and then specify and then make the car act in a certain way that interacts with our mock object in a certain way, and we create an assertion of the way the car should react, and then we implement the functionality for car. So this is an example of test-driven development using JUnit and Makito, and most test-driven development follows this approach, and mock objects really give you a way to have finer gradations of abilities to test your actual object. So they're really useful for test-driven development. Some people use them for isolation, for saying basically if a test only has mock dependencies, then if the test fails, then you know exactly where the problem is. But it takes a long time. Sometimes some mocks can be pretty. Mocking certain objects can be hard sometimes. So I don't test in complete isolation. I tend to use mocks for test-driven development, and you get unit tests and the code at the same time. not complete isolation, but good enough for debugging most problems. Anyways, this tutorial has been a lot of fun. I hope you guys found it helpful, and if you did, like and leave a comment below if you want, and subscribe. Thank you for watching.